Good evening, good evening. It's one of our last days together. I know you guys are really gonna miss me. I'm really gonna miss you. Just, I would not rather see you at nighttime because Mrs. Main's an early riser. Mrs. Main would rather like, if you want to meet for coffee in the morning, reach out to me after class. I'll share my real cell phone number and we can have coffee on Zoom, but really not a night person. I'd like to hit on a few things as we're wrapping up the semester. If you have not, the people that are not answering the email are not the people watching this video anyway, but anyway, if you have not responded to my email regarding when you're going to take the final exam, please do so ASAP. I'd appreciate that. It's a quick survey. Also, there will be a survey coming to your email, to an email near you as course evaluations. Please fill those out for all of your courses, especially if you're not happy with something going on in the course, whether it's mine or another course or with an instructor. They will not ever know who specifically said anything. And they will not even get the information or the data till after grades are in. So you don't have to worry about your grade being compromised, because you said something. And even after I get the data and even the words that the comments that you actually type in, I still don't know who wrote them. So don't feel like I would ever know that or another instructor, but they are important. The deans look them over. They see them. Instructors that care, I should say, will look through them. But we do want that feedback. So please fill those out for your instructors for all your classes. The other thing is I had a student reach out to me today and, oh, yep, there's also going to be an evaluation for April that she wrote in the chat. Also, this morning, I had a student reach out to me and she was asking a couple questions on the chapter 11 review. So we did like a quick 5-minute like scenario of what you should work on. And I'll probably hit on it again tonight when we work on some of these chapter 11 overview pages. And I put that right here at the, during this week, right here. So I put, under tonight, it says extra chapter 9 to 11 review, 5-minute video. That's new. That's not the one that was there that I took down from last semester because the link wasn't good any longer. It's actually the one that I did this morning. And I wrote in there 5-minute video, so it's pretty short. But hopefully it will guide you in thinking about, so when you're working on that chapter 11 review worksheet, you may have went, whoa, this kind of hit me like a brick, because you have to be able to discern what are they talking about, right? And so we're going to work on that tonight. I updated everybody's grades in JetNet with their current my stat lab score. So anything that's past due up through chapter 10 went to a 0. You can always go back and work on those, but I want everybody to, I've really tried to do that this semester, which I do every semester. I try to keep your grades as current as possible because I don't want anybody to ever say, she never let me know where I stood. So you should always know where you stand in my class. I send emails if I'm concerned about you. I send emails if I think you're amazing, which I think you're all amazing, whether or not you do well in my class. But you should always know where you stand. So your my stat lab score is current in your JetNet grade. So be monitoring those. If there's anything that you had turned in that you feel I did not grade or did not grade appropriately, let me know that. If it was past due, I may not have time to go back and do that. I want to grace the semester, but things are getting ramping up and getting busy here. So that's kind of where I stand with that. So I've got a couple other people joining us now. So I think those are the main things. So how about, actually, I say we start with the chapter 11 pages and then we go to the little review worksheet. So I'm going to flip flop around what I had on my Google Doc, if that's all right, if I have the liberty to do so. So let's flip these around. Let's do the chapter 11 guides first. Because I think folks at home will probably appreciate those most. And then if they don't need any help beyond that, then they don't need it. So the pages, at least the pages I have are page 255 through 257 in your course pack, if you have those out and set aside from the Google Doc. That's where we're going to start. And it says confidence the first page says confidence intervals guide for chapter 11, but really it's chapter 9, 10, and 11, all of these, because they include all of the one sample information as well. So, and here we go. Those that just came on, on live, what in the heck? Live on the live call, I have a 5-minute review video. If you want to catch it, it's on in our JetNet page. What is going on here? It will not go to my. This is really weird. My goodness. Okay, so that's sharing that. It won't go to my dot camera. Shares. Wish me luck. There we go. Wonder of wonder. Can you guess the musical that I was just singing? Anyone? Anyone? Anybody know their musicals out there?
Do it again.
Want me to do it again? Wonder of wonder, miracle of miracles. It's an old one.
Is that the Jesus Christ Superstar?
No.
No.
I'll give you a word that might help. Mazel tov.
Fiddler on the Roof.
Nice. You crushed it. I was
Never
in
heard of
the freshman year.
Really? You
Yeah.
haven't? It's a good one.
It's a great one. Yeah. It's actually, you will learn a lot about the Jewish community, and it's a really good musical. Okay, here we are. The Confidence Intervals Guide for Chapter 11. So you can see that they're all of these are like the TI-84, but that's okay. We're going to also add in all of our knowledge of StatCrunch tonight. So these are actually confidence interval guides for chapters 10 and 11, because there's 5 here. So you're probably wondering, wait, we didn't do 5 formulas, 5 confidence intervals for chapter 11. That's because we mixed them. So you're going to be looking for the first thing that you're going to look for in all of these problems when you get to the final exam and the sample final exam is, are they talking about quantitative or qualitative data? And if you are tired of me saying that, then that's good. You know what's going on. If you're not tired of me saying it, then you might be like, maybe that's something I should ponder a little bit longer. Because it is telling you everything you need to know. So if it is talking about, and we don't ever say in the problem, it doesn't say, hey, this is quantitative data. Hey, Sarah, this is qualitative. It says things like, if there's values that are measured, if it has units, dollars, right? Centimeters, weight, time, numbers of things like the number of books, right? They average the number of books, okay? Books are my units. It's going to be talking about means. So you're going to look for everything in your gold pages that has to do with means in the title of the gold pages. If it talks about proportions or percents, the percentage of people that did this, the percentage of students, the percentage of fish, the percentage of colleges, you are going to be looking for the word proportions in all of your gold sheets, okay? This is where it starts. Then you are going to decide, am I talking about 1 sample or 2 samples? And this page here that we're going to fill in is all about confidence intervals, and you're going to be looking for the words construct a confidence interval. Your end result should always be, I'm getting a lot of this semester, which I've never had, people in their projects turning in and only doing some of the formula. You're not giving me the end result. So the end result should be a lower bound from the confidence interval and an upper bound. Okay, that's going to be your end result. And depending on the situation, you're going to have 5 different options. So the 3 from chapter 10 are on this page here, page 266. I'm sorry, 2 from chapter 9, chapter 2 from chapter 9. This is chapter 9. This is because it's confidence intervals, it's chapter 9 and 11. Hypothesis test would be 10 and 11. So if we're talking about qualitative data, and we're talking about, notice the word proportion that I mentioned. If you're using the TA84, you're going to use the 1POP-Z int. If you're using StatCrunch, you are going to go to stat and proportions. So that's just right. Oh, let's just do a little mark that separates it here. And then we're going to do our directions here. Instead of looking for, what you're looking for is constructing a confidence interval. Let's just do here for StatCrunch. You're going to go to stat, proportion, stats, and then one sample, because you've already decided that it's one sample. Okay, and then you're either going to have summary statistics or you're going to have data. Okay. The gold sheet, it's 266. Gold or yellow sheet, however you want to say that. And this was chapter 9.1. And the parameter that you're estimating here is a population proportion, P. Okay. And you're going to have a point estimate. And that's P hat. And whenever you're talking about proportions, your normal requirement, your normality requirement is always N, P hat, Q hat has to be greater than or equal to 10. Now, if you went through your list and you said, yep, it's proportions, but it's 2 samples that I'm comparing, right? 2 proportions, percentage of men versus percentage of women or whatnot, then we're going to be in chapter 11. Okay. Our normality requirement is the same, except for you have to do it for both samples. And 1 P hat, 1 Q hat 1 has to be greater than or equal to 10. And N 2 P hat 2 Q hat 2 also has to be greater than or equal to 10. And again, we're estimating, you're estimating the difference in proportions. So the parameter is P1 minus P2. And this is chapter 11.1. And when I reference the page, I'm referencing your gold pages because that's what you're going to really need to know for the exam. So these are all going to be the gold sheets. Okay. Everybody following so far? And hopefully tonight you're like, okay, this is making sense. I'm following along. Now, when we go to do StatCrunch, it's going to look very much like what we put up here, right? Except for when we get to the spot where it says 1 sample, we're going to say 2 samples. So it's going to be stat, proportion, stats, and then 2 samples. And then there could be summary, or it could be coming from data. And I thought it would be good. I'll come back to that, but I thought it'd be good if I was at StatCrunch. If I just showed you this, the stat and proportion stats is right here. One sample looks very much like the two sample. Okay, one, and then within there, let's say I have summary, I'm going to be putting in the number of successes. This is what you need to write down. Both of these, and I'm going to draw it on my paper here. So I'm going to write down and I'll show you for you to write on your paper. Okay. So I'm going to X out of this now. I'm going to show you how you could add to your paper here. So on your guide for these two, you could write on here, this is what StatCrunch is going to ask you for. And number of successes is X, right? And number of observations is N. And you can even write for yourself sample size. That's what we focused on, little n being sample size, sample size, sample size. But it's really the number of observations that we collected, and X is the number of successes of whatever we decided. So let's say we collected everybody's eye color, but I really only wanted to know the number that had blue eyes, right? So X would be the number of blue-eyed people out of everybody that answered the question from the class. Are you with me so far? That's what you're going to need if we're talking about proportions. Okay. Are all my peeps good? All my live peeps? I'm gonna stop sharing for a minute, just so I can see everybody's giving me the thumbs up. Are we okay to move on to the rest? Okay. So now, if we had means, if we were talking about quantitative data, you asked yourself this question number one, and you said, yep, I have values that are measured and I have units. So I'm looking for only things that say means on my yellow gold sheets. And now I'm asking myself, do I have one sample or two? I'll decide that, but we're going to look at confidence intervals. It's still saying construct. I want to construct a confidence interval. And the first one we're going to look at is from chapter 9. And that's on page 266. So gold sheets 266. And it's 9.2. We're talking about a confidence interval for a population mean. So the parameter that we're trying to estimate is the mu, the mean. And now all three of these are going to have a different requirement. Okay, this is when they're all three of these are going to have sample size just needs to be greater than or equal to 30. And each of these are going to be your, because you have two samples on both of these, right? Has to be greater than or equal to 30. And I know I'm skipping down here, but I want you to see the similarity between some of these things, because these are all two sample. These two are two sample, that one's one sample. So 9.2 and 9.1, I'm circling those. Those are one samples. So up here, chapter 9, one sample. Chapter 11 is two samples. Okay. So here, if we are going to StatCrunch, we're going to go to Stat and T-Stats. And then under T-Stats, you're going to choose one sample or two, but you're going to choose one sample for this one. And then you're either going to have data or summary. Okay, and the summary for this is going to be similar to up here, the summary is going to be X and N, right? Now down here, when you get to the summaries, the summary is going to be X bar and S. It's going to ask for. So if you're like, oh, yep, I'm following here, I'm thinking it's this one, I'm going to stats, one sample, data summary. I got summary data, and then you're like, oh, it's asking me for an average and the standard deviation. They told me 6 out of 300 people said they had blue eyes. That's not at all this, right? So that's where you really want to make sure you're following this. So you're like, oh, when you get to something that doesn't make sense, it's like, oh, I really have this kind of data over here. Okay. Next up, we still agreed that we had quantitative data that has measured and it has units. We're dealing with means, but now we answered the question that we have 2 samples. And here, the t-integral for differences, this is chapter 11. And this is because we have matched pairs differences. So we're really just doing a regular old sample, one sample, but it's on the differences. So under the look for, we're looking for matched pairs.
Yes. Can you do them together? I tried to add it
I'm
on.
gonna mute. Okay, so I'm gonna go to StatCrunch because I want, this is the one that is slightly different. So I want to make sure everybody can follow along with that. So if we have matched pairs data, we're going to stat and t-stats, but notice it's not one sample, 2 sample, we're going down to paired, only if it's this matched pairs data. So we're going to stat, arrow, and then we're t-stats. And then you're going to paired. Okay, and so if you have raw data, you're just going to go and put the data in sample 1 and sample 2, and it will calculate the differences for you. And you can even say, click here in the box and say save differences like we did in class, and it will save the differences so you can fill those in the table. Because usually if we give you one on the chapter 11 worksheet or the final or the sample final, we're going to give you a before and after or comparing 2 groups, and it'll say differences. That's a hint. It's this one. Okay, so don't worry about calculating those by hand. Don't get stressed. I would put them in StatCrunch and just label your column 1, your column 2, and put it there. Now, the cool thing is if you are taking your final on the computer and you're using StatCrunch, you can, and even if you want to do this and turn it in separately, start a Word document, even if you're doing some of it on paper, but you want to have your evidence, you could title these in Word document and then go in here and copy and paste, right, all of your outputs as you do outputs in StatCrunch. That's just a little bit more evidence for me for your partial credit. That's a great thing too. If you're like, you know what, I'm not sure I chose the wrong one, or right one, but here's my output and I can see what you chose. And then that helps me give partial credit as well. Like, oh, I see they just had it in the wrong direction, but that's where their information came from. And that, you know, what they did from there was correct. It's just, if you get off on the wrong path, right, on these problems, it does kind of take you down the wrong lane completely. So I try to make sure I can give as much partial credit as I can, but if you're just plopping down just this over here, the lower and upper bound, I have no idea where it came from. It's hard for me to give partial credit, but if I can see some evidence of what you were doing, that's helpful.
If we do it on paper, can we just like write down what I guess what function we use, kind of like we did in the chapter 11 worksheet?
Oh yeah, by all means. So if you said you went to stats and t-stats in one sample with paired data, now if you already came up with your differences already and you just did one sample, that's fine, because it does become one sample with the data's already been differenced, right? But yeah, as long as you're kind of telling me what you're doing, that helps, because I'm like, oh, you went to t-stats, you really should have went to proportion stats. that's good for me to be able to know.
Thank you.
Okay, paired. Yeah, okay. The parameter that we're estimating here is the mean difference. So the mu D, this is 11.2, and on the gold sheets, it's page 269. And then the last one is quantitative data, but it's just 2 independent samples. So 2 independent samples. And the parameter that we're estimating is the mu1 minus the mu2. So if we had both populations, we could do that. This is section 11.3, and it's still on the gold page of 269. And then the 2 types of critical values that we use for confidence intervals, we use a Z critical value, a Z alpha divided by 2. And we also use a T critical value of alpha divided by 2 with degrees of freedom. And let's just reiterate how we find those critical values. So if we want to be able to get the critical values, we're going to go to stat, and you would go to Z stats, right? And that will give you your, I'm sorry, calculators is what I meant to say, calculators. I'm going to write this down at the bottom. So you're going to, both of them, you're going to go to calculators. And the Z, you're going to go down to the normal. And then you're just going to enter the between. And I'm going to draw this picture for both. So I'll show you what I'm going to draw. Mean and standard deviation. And then this is going to be a between. So you click on the between, and then you're going to enter the confidence level. Right? It's going to go in this box. So I'm going to show you how I would draw this. If you all want to copy it down on your sheet, I would have something like this on your sheet. So you're going to go to calculators, and then you're going to click on both calculators and normal. And then between, and then it's going to come up like this, and you're going to enter the confidence level in between here in decimal form. And in this case, because our scenario is we're using all Z scores, right? So our mean that we're using is 0 and 1. Now, if we're talking about particular scenarios back in chapter 7, like the mean weight of giraffes, and I want to know what is the likelihood of a giraffe being bigger or smaller or something, then we're going to actually have the average of the giraffes and the standard deviation. But we're just talking about critical Z values, and so the Z's mean is 0 and its standard deviation is 1. So this will be blank and blank. Blank, blank. The only thing you enter then is the confidence level, and you're gonna put that in decimal form right there. I'm gonna kind of wait till everybody gives me the okay. Brendan's good. Okay, I'm gonna stop sharing, just make sure it's everybody giving me the okay that we can move forward on the T, critical T values. Hillary, Abby, Kara, Andrew, Joanne, okay. So. I'm gonna go back to this. Okay, let's get out of that one. So I want to find a critical T value. I'm going to go to stat and calculators, and then we're going to go down to T. And then on my T calculator, I'm going to hit between. So we're going to go to calculators. T, and then choose between. And then the only thing you have to add here is the degrees of freedom, which is amazing. And then, between. And then you have to put in your confidence level again, but your probability. Your confidence level is going to go right inside there. So that's what that looks like, but I'm going to show you on my paper. So you're going to go to calculators and the T and choose between, and then you're going to enter your degrees of freedom, right? Which is n-1. And then those are going to be blank and blank. And then you're just going to add, put your confidence level here. Okay, thumbs up from Nikki. I think everybody else is giving me all the thumbs up. I can tell. Okay. Okay. So that is the confidence intervals guide. I'm sure that seems daunting. But now that we've kind of got our pattern right, because the cool thing about StatCrunch is this, like, once you've chosen your T or proportions, it kind of all gets dictated from there, and then it's kind of a repeat and all the other things. So let's go to the sample size guide on page 256. Okay. And while we're doing this, I think it would be appropriate to look at the chapter 9-11 review worksheet, page 662, kind of simultaneously. It's this one right here, because it's actually having you read through scenarios. And I think while we read through these, then we can fill in this sheet at the same time. I think it would be help you to kind of go through it and say, oh, this is what they're asking me. This is how I know I need to go look at that. Because A, B, C, and actually D and E, all of question number 1 are referring to sample sizes. And there's 5 here on this chapter 11 review guide. And then there's 5 here on this worksheet. Is everybody okay with that? We'll kind of read through those and see how we can decide which is appropriate. So let's read through, and we're asking ourselves the very first question. We're going to force ourselves to read through. Is it quantitative values that are measured with units, or is it proportions? So let's answer that first question here on A. Oh, Jesse has his helper again. So if anybody has a thought, just chime in with what you think. Is it,
I believe it's looking for a proportion.
okay, well, give us that clue.
It's mentions 82% of all voters.
82% of all voters. So it's something that tells me we're talking about proportions. Okay. So we answered that question. And then we already know they're asking for sample size, right? Because at the top of the problem, it says determine which formula is appropriate for computing the minimum random sample size. So that's what they're going to be looking for to know. It's going to say how many or what sample size. Okay. So this is proportions. And our next question is it dealing with one sample or two samples?
One sample, because they haven't yet done the follow-up survey.
Yeah, so they want to do another survey, and they have prior data, right, from the previous, from this previous survey. So that's our question there. That's kind of an additional question that we have to answer because down here on the bottom of page 269 is it says with prior estimates or with no prior estimates. So let's write on here, this is proportions. Let's make a note of what we went through. So it's proportions. One sample with prior data. So I'm on the wrong page because that's chapter 11. We should be on page 266. And we're with this prior estimate down here. So N P hat Q hat or P hat 1 minus P hat. Right. So this would be our choice on this one. So we see that we have some prior data that we're going to use. The prior data is what they said right here. That last year they did a survey that said 82% of all voters believe climate change exists. So we found this on page 2, gold sheet 266. This is section chapter 9.1. And then we're looking for proportions. And it's with prior data. Okay. And so the one that we're going to write down is P hat, Q hat. And then we have the critical value divided by the error squared. So our critical value is the Z critical value. Agree with me so far? So let's look at letter B. Let's read through that and ask ourselves the first question. Is it quantitative or qualitative?
Quantitative. because there's no percentages dealing with the data, only for the confidence interval.
Okay, so you didn't see any other percentages. And also, what are we measuring, or what is the units?
IQ scores.
Okay, and they don't really have a unit, do they? That this is a hard one, but they're measuring your,
I guess points
yeah, points. would
they're
be-
using.
Okay, so this is means. And sometimes they even say mean, they did, so that's good, okay. And is it, did you say it was one sample or two?
It's one sample
Okay, so one sample,
with no prior data.
okay. So when we talk about means, the cool thing is we don't have that option of prior data or not. There's only one formula for that, one sample size right here at the bottom of page 266. So we're looking at the first choice here, right? This one right here. Okay. And so that's page 266 as well. That's 9.2. And that one is the sample standard deviation times the critical value divided by the error squared. And with sample size, we always use the critical Z. So the critical values are always going to be the same on these. It doesn't matter if it's proportions or not. Everybody with me so far? And so we're looking for means quantitative units of some kind. Okay, so let's look at the next one. Let's read through letter C and see if we can figure out what type of data we're talking about here.
It's quantitative, but this time it's using two samples because they're comparing men to women and separating them that way.
Okay. So it's two samples. Okay, they're comparing men and women, and it's still IQ, so we know it's means. And we said it's two samples because they're comparing men and women. Okay, and so we need to decide which test are they using there. So that's chapter 11. We're going to go to page 269. So let's write that on here, page 2. Oops. We're going to do a two sample one. We're going to scoot down here for just a minute because these are our 3 one sample ones up here. So this is going to be 11 point. Excuse me. Did they not? For the difference in their average scores. And I think we cut this out now that I think about it. Let's see here. How many people? I think we can do, I think we can use. Let me get back to my sheet here. Use this one, but we don't really talk about it anymore. But I think we can use this one. Some people for the difference in between. So in their difference in their average scores. I'll go to my course pack momentarily here. Okay, so letter C on this review worksheet is, it is means and it's two sample, but we don't address which sample size anymore. And it's not this one, because this one here, this bottom left one, would be if we were talking about proportions between two samples, and we're not. They're talking about their score, right? Believes that they scored differently, not the percentage of people that are taking that the IQ test, but how they're scoring. So it's a difference in their score. So we used to do that, but we don't do that on here. So, and that was a mistake on that one. So let's go to the other two. Here. And we'll make sure that we fill this in, don't worry. So let's look at letter D here, the credit card company. It's about to send out an electronic mailing to test the market for a new credit card. From that sample, they want to be able to estimate the proportion of people who will sign up for the card nationwide. The proportion. So I gave that away, right? So we're dealing with proportions. Is this one sample or two?
One sample because it's not comparing one thing to another.
I'm sorry, what?
One sample
Mhm.
because they aren't comparing one percentage to another.
Right, yeah, they're just saying, what is the percentage of people that are getting credit cards? And so we go to our yellow sheet, which is back to chapter 9, because it's one sample. And we don't have a prior estimate, so it's this last formula here that we haven't used from chapter 9, right? So it's the 0.25, it's this one here. So on our sheet, it's this one right here. This is from chapter 9.1 as well. And this is proportions with no prior data. And that's 0.25. And then the critical value divided by the error squared. Okay. And the last question, then we'll take a little break here. Ease. Let's look at this one and see if we think it is means or proportions. And looking.
Portion,
We think it's what?
portion,
Proportions. Okay, I do see some percentages there besides the confidence level, right? I do see other percentages, so proportions. And do we
Sample.
think one sample or two samples?
two,
Two, because they're comparing Michigan and Ohio voters. So it's 2 samples, okay, and so do we have prior data from before?
Um,
That's
No.
a- So they say from a prior survey, we know blah, 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 because that would be this one down here. Do we know prior data?
No.
Because we're looking for sample size, we're not doing a confidence interval. So do we have prior data to help us with our sample size?
Yes, because that is the prior data. They're looking to make a new
Yeah,
one for this year.
yeah, because it says, how many people would you need to survey in order to construct for this year? So last year it was 31% of Michigan voters and 24% of Ohio voters. So we have prior data. So we're using this one right here. So that's gonna get filled in right here. So look for 2 samples with prior data. And that is 11 point, I think it's 11.1, isn't it? Oops, 11. I was doing the wrong page. That's 9.21. And this page was 269. And this was 266. Okay. So this is p hat 1 minus p hat 1 plus p hat 2, 1 minus p hat 2. And then our critical value divided by the error squared. The only one we didn't have an example of was it's 2 samples, proportions, no prior data. And I think there was one on the sample. I know, let me just look. No, but if you look at problem number 5 on the sample final, it's similar to what we just did on this review worksheet. So kind of take a look there. That should help you on the sample final problem number 25. So on this one was 2 samples, proportions, no prior estimate. We didn't have an example for that tonight, but that's this one here where we're using 0.5 times the critical value divided by the error squared. And that's on page 269, and that's also from 11.1. And again, all of our critical values are always Z critical values. Okay. Okay, so now we're looking at our hypothesis test guide for chapters. Actually, it's 10 and 11, right? And this is on page 257 in your course pack. And the first question you are asking yourself, as usual, is do we have quantitative, where's my sheet? Here it is. Do we have quantitative or qualitative data? And do we have 1 or 2 samples? And are they asking us to test the claim? That's what they're gonna ask. It says conduct a hypothesis test. On the what to look for, we're just gonna put this over here. It's gonna say test the claim. That, whatever. Okay, so if we have a scenario where they say it's one sample and it is proportions, we are going to, this is from 10.2, and this is going to be page 267 in our gold sheets. Proportions. One sample. And so the cool thing is I think this little guide that I'm having you think through is actually going to help you walk through StatCrunch, because we do the same thing, right? Proportions is what we go to, stat proportions or stat T-stats, right? So this would be stat proportions, then you're going to choose one sample, and then you're going to say hypothesis test. So, and your hypotheses is going to be, you're hypothesizing with the P is what you're predicting there. Not predicting, but you're hypothesizing a claim against it, right? And then your requirements for normal are N, P0, Q0 have to be greater than or equal to 10. So remember, whatever you have in your hypothesis statement is what you're using over here. So that's where some folks were getting hung up on their chapter 10 project in the CLT requirements. You had to use 0.2 and 0.8 because we're not using our P hat. You're using what you think your claim is in your hypothesis statement. So for our chapter 10 project, it was 0.2. And make sure you're showing me all of the steps in your hypothesis statement. Okay, now let's say you look at a scenario and we can tell that it's means in one sample. So if it's means in one sample, we're going to be looking at 10.3, which is a t-test. And that's this one down here. So we're skipping one for just a minute. That's a t-test. So this is means. And it's gonna be t-stats is what we look at in StatCrunch, right? And it's one sample. And that's 10.3, and that's page 268 on the gold sheets. And here our H0 is that the mean is equal to some value, right? And the same way up here, this is some value that we're going to put in. So there's a numerical value that goes in there. You might want to make sure you have a note for that. Some numerical value that you're testing against. Our requirements for normal here is just the N is greater than or equal to 30. These are both our one sample situation. Okay. Now, if we go through our rubric and we say, oh, I've got proportions, but this time I have two samples I'm comparing, like the Michigan voters and the Ohio voters, right? And I want to test a claim. That's going to be chapter 11. And this is the page we're going to use, page 270. you're going to need X, which is your successes, N is your observations. So this is 11.1. And this is proportions. To sample. And our hypothesis here is we're just stating P1 equals P2 and then our comparison. So you're just following everything on this gold sheet. Once you've decided on what gold sheet, so if you went through this page here in your guide and you're like, oh, I need page 270, you're going to go to 270 and everything is here. Now on the final, only if I say, show me the requirements, do you show these up here? Otherwise, you're just going to go straight to step 1 through 6 if it says test to claim. Okay, only if I say the same thing on the chapter 11 review worksheet on like the first page where it says 1, 2, and 3. I think they're just all asking for confidence intervals. I'm not asking you to show the requirements. Assume they're met unless I ask you to explain those. And then when it's 2 samples, make sure on your normality that you're testing here that this is N and then P0, Q0, P1. These are the P hats for P hat 1 and Q hat 1. It's got to be greater than or equal to 10, and then N, P hat 2 and Q hat 2 is greater than or equal to 10. Because you have two samples that you're comparing to each other. Okay. Then our last 2 situations are chapter 11, 2 samples, means. But this one is, the first one is the matched pairs where they're dependent samples. So matched pairs. So we're going to go to, and you're going to have 2 samples. So in StatCrunch, you're going to go to T-stats and then paired. Remember, I showed you earlier for the confidence interval, it's the bottom choice. And then you'll go from there where your data is. So this is section 11.2. And this is gold sheet page 271. And here, the hypothesis statement is set up as the mean differences are equal to 0, and then you're testing a claim otherwise, right? This page 271. So it's the mean differences. So this is the one where you actually have to calculate a before and after difference. And the requirements for normal are just your sample has to be greater than or equal to 30. Then the last one for these pages tonight is our 2 samples, but they're 2 independent samples. So we go to T-stats and 2 samples. And this is 11.3 and page 272 in our gold sheets. You're going to follow everything from here. And your hypotheses is going to be just comparing mean 1 and mean 2, because they're two independent groups. And then here you're going to have, you could have different sample sizes. So you have to make sure that sample size 1 is greater than or equal to 30 and sample size 2 is also greater than or equal to 30. Any questions so far? Oh, that was a lot. Okay. So I am going to open it up for questions on the chapter 11, not 11, your chapter 11 review worksheet. If folks have questions on this, or if you have questions on the sample final that you want to start asking. And we can also finish up the chapter 9 through 11 worksheet that we had started page 663.
Is the exam just chapters 11 through, or 9 through 11?
No, it's essentially the whole semester, but the focus is on 7 through the focus is on 7 through 11. But I might, things have been brought up from the whole semester. Jeez.
Okay.
So you'll want to look at these scenarios on starting on page 663. And we can kind of just look through and mark if they're quantitative, qualitative, and what they're asking for, 1 sample, 2 sample versus hypothesis test, confidence interval. So let's look at number 2. It says math and verbal SAT scores for a sample of 100 disabled students were used to perform a hypothesis test about the mean difference, math minus verbal. It says what calculator entry would be used, but let's focus on, is it means or proportions? We could kind of go through those scenarios.
It's a mean,
Okay. So
because they want to know specifically how many.
They want to know how many, or you mean they want to know what their score was?
The score.
Okay. So we know we're not doing anything with proportions, right? So we've got means, which is going to tell us that it's T-stats for the stat crunch. And then do we have 1 sample or 2 samples?
Would it be 2? If they're talking about math and verbal scores? Both independent scores. Wait, math minus verbal. Yeah, and plus they say mean difference as well.
So are they comparing, remember there's two possibilities in chapter 11. Is it two samples measured one time, or is it one sample measured twice? Are they matched pairs? Is it one group of students that you gather data on twice?
Yeah, because it says the scores of a sample of 10 disabled students.
Of what?
So it's, or 100, I can't read.
Okay,
100 of them.
so this is matched pairs, right? Because they said they wanted us to do math minus verbal. So this is 11.2. When we look at the, we just did, this would be our 11.2, the match differences, right? And they wanted a, it would be a hypothesis test. Okay. Let's look at number 3. It says math SAT scores for a sample of 100 disabled students were compared to those of a sample of 100 non-disabled students. Researchers wanted to create a confidence interval to estimate the true value of the difference. Oh my gosh, I'm a mess.
This will be two samples measured once.
Okay, two samples measured once. What section is that?
That is 10.3. No, excuse me. That's 11.3.
Okay. So it's 11.3. These are not proportion stamps. Okay. Let's get the next one. Four. Let's look at number 5. As a researcher wants to test whether a new drug lowers the rate of heart attacks when compared to a group who takes a placebo.
This would be two samples measured once.
Is it two samples measured once?
Because they would have to have a control group to tell if it worked. For placebo and then a new drug. So they would have two groups. Or maybe it, I'm talking myself in a circle here.
That's right. Yep, that's good to kind of talk through. Anybody want to chime in?
I mean, I kind of had the same thought. There's two different groups being tested.
Okay, so two samples. And we never answered the question, are they proportions or is it means?
This would be a mean.
If it's means, what are they measuring, just so we know?
How often a heart attack happens.
So how are they measuring the oftenness?
By this is rate of heart attacks.
Which would make it a proportion.
Okay. So the rate is telling us that it's proportions. And so there's two samples, so this is 11.1. And they wants to test, so it'd be a hypothesis test. Okay, what about number 6? I'll let you guys talk through it.
So with the average distance, that means they're looking for a mean. Parents of newborns. Which would be
And-
one sample of data, the population being parents of newborns. And with average difference, that would be a mean. So a one sample mean would lead it to be a t-test from 10.3.
Well, there's 2 samples because they're talking about the difference in age between the mothers and fathers, which is then the paired because they are, dependent of each other.
Okay.
Which would make it 11.3 instead, 11.2 instead.
Okay. So I'm glad we're talking about this. This is bringing up lots of different situations, right? So it is matched pairs. Okay, and they wanted to estimate the average. So is that a hypothesis test or a confidence interval?
Confidence interval.
Yes, confidence interval. So it would be, if you were using a TI-84, it'd be a T interval. And this is means. Because they said average. Okay, what about 7? Statistician is asked to test whether incoming freshmen in Michigan State this year had an SAT average score higher than last year's incoming class of 1,200.
They're looking at means because you can't have a proportion for the SAT. And it's 2 variables measured once because they're comparing last year's to this year's.
Hmm. So are we comparing 2 groups of data or are we comparing one group to a previous average? An actual value?
One group to a previous, so it's comparing to prior data.
So this is really one sample. And we're comparing it to this value of 1,200, right? Because they asked if it was higher. So it would look something like that. Higher than 1,200. Jeez. What about 8? The decision is asked to test whether among the incoming freshmen at Michigan State University, the female students have a higher SAT average score than the male students.
Looking for means, so I know it's not proportional.
And it's 2 different groups because it's separating the male students from the female students.
That's what I thought.
So would they be matched pairs or would they just be independent samples?
They'd be independent samples from each other
Okay.
What?
because it's all females compared to all males that are incoming.
Mhm.
Even though they are all freshmen, that doesn't determine whether or not the other group's a freshman. I get,
Well, we're just taking this group versus this group instead of
Exactly.
like actual pairing people up.
Mhm.
Mhm, that's a good question. Those get tricky. Okay, what about 9?
It's another mean calculated one because it's still talking about the SAT.
Mhm.
And it would be matched paired because they're comparing the verbal and the math.
Okay. So it's mean match pairs. Because they're comparing students, their verbal versus their own math. Okay. And they wanted us to do an estimate or test a claim. Test a claim.
So a hypothesis test.
Yeah, test. What about 10?
It's going to be proportional because it's asking about the percentage of all healthcare workers.
Percentage is proportional, okay.
And there's only one sample, which is healthcare workers.
Okay, one sample. And what are we doing? A test or a confidence interval?
A confidence interval because we're estimating.
Okay, so when we're estimating, that gives us a hint that we're doing confidence intervals. Excellent. About 11 and 12. I'll be right back. I'll let you guys talk through this one. For these two.
So it's a hypothesis test because they state test on there. They're doing a poll.
No, the poll is to do the testing. We
Mhm.
aren't testing.
Okay.
They're taking the percentage from the poll
Okay,
that
that
is
makes
doing the
sense.
testing.
Okay, that makes sense. Okay. But it's still, it's a one sample though, because it's coming from, it's coming from the people who took the poll.
Yep, and it would be a hypothesis test because they're looking to see if it is greater than 50%.
Okay. She came back around, Brendan. You said test.
I had to talk through it first.
Yeah, no, I like it. You guys are showing this is what you think about, right? When you're
Mhm.
reading this, and it's like you got to think, these are the things that you're talking to yourself about. You're right, because they were looking to see where there was at least one. So did we say this was means or proportions? I missed that.
Proportions,
Okay.
because they're looking for the percentage of all viewers.
Okay, yeah, majority would be greater than 50%. That's something to remember too. Okay, one sample. What about 12? Jesse's little one is chiming in. Is it one sample or two?
It's one sample because they're just testing to see if people,
They're
they're just
looking for
testing people.
average of
Mhm.
number of minutes, which makes it a mean too.
Mhm.
Okay.
But it's not a test, it would be a confidence interval.
Mhm. This has the word estimate,
Okay.
keywords.
Good job. Estimate tells us it's confidence interval. Great job. Okay. You all want to go to the last page 13 or question 13, or do you want to, does anybody have any questions that they want to, bounce in about regarding the chapter 11 worksheet? I want to make sure I'm giving folks the opportunity to. Let's go through 13 while we're here. So it says for a student project in statistics, a student asks the following research question. Is there a difference in mean hours slept by on-campus and off-campus students? Give at least one reason why on-campus students might get more sleep.
There's a very small amount of time to commute and compared
Okay.
to someone that may be living like 20 minutes out.
Okay, yeah, less commute time. Give at least one reason why off-campus students might get more sleep.
There's less partying or socializing going on potentially.
I went with there's more of the familiarity of being home. That one works too, though.
So less potential for distractions. And more familiarity, okay. Explain how age can be a confounding variable in conducting this research and how the researcher might deal with this in the research design. because who usually lives on campus?
Those of us that are in our teens and 20s.
Right, and who usually lives off campus?
The real adults,
Grown folks.
the adults.
Are like old folks like me, they go to bed at 10 o'clock, right? So
That's late.
age could kind of dictate when you go to bed, not just the fact that you live on campus or don't live on campus, right? So,
Right.
so how could we maybe think about that in the design of our study?
Could have two separate surveys, one for those that are between the ages of like 18 and 25, and those for 26 and older.
Okay. And thinking about the C wrapped into D, which sampling method might be the best for collecting this data? Because we kind of have one group that we want to get some information about, right? The people that live on campus that are younger, and we kind of want to get.
So we probably want to use systematic because we want to narrow down on those who we're surveying.
Systematic was you're systematically maybe taking every 10th person. Let's say if we did by their student number. So that's really not giving us
Stratified.
Where we took a little bit of each group. Somebody maybe just said it.
Stratified.
Yep. So stratified would probably be the best one here because we're getting a little bit of from each group of people, right? So random sample. Groups. And would the sampling then be independent or dependent in this situation?
It would be independent because one doesn't affect the other.
Okay, so there'd be two different groups, right? So independent. And is the data that we're going to collect on this quantitative or qualitative? What are we going to collect?
Quantitative, because it's the mean hours of sleep.
Okay, hours. Good job.
And it won't be proportional because it's, again, the mean hours.
Mhm. So,
It would, however, be an independent 2 samples of data.
an independent 2 sample, I would probably agree with that. Um, two samples, independent, okay. And we'd be testing, and then I size, if she wanted to estimate the difference in their average hours, we still have means, 2 samples, independent, except for testing, we're estimating, so this would be a confidence interval, right?
Yes.
And then J, our last question. After conducting the research, she reports that there is evidence of a significant difference in average hours of sleep for the 2 groups. A fellow student sees the results and claims that it is not practically significant. Excuse me. So how can they both be correct in this situation?
If the sample of people was less than 30,
No.
I tried.
Yeah, I like your thought. So if it's a significant difference, we're using numerically, right, speaking. So numerically, we reject H0. But a practical significance means it does not apply to real life if they say that there's no practical significance. Now, if you could prove that getting more sleep actually affected your grade, then it would have some practical significance, right?
Right.
If you had it tied to something else, but if you're just like, yep, they get different hours of sleep. Well, okay, what does that tell us?
So they're both correct because she is not applying the data to another set in comparison.
Right. Right. Okay. So, what questions does everybody have? Do you not have any questions? I'm gonna stop sharing and just see where everybody stands as far as. Any questions anybody has? If not, you can send me questions, send them my way. You have your chapter 11 review worksheet is due tomorrow night at midnight. I won't have time for like send backs, redos and all that good stuff. So make sure you're watching the videos, make sure you're going through the rubric we went through tonight. Is it means or proportions? Is it 1 sample, 2 sample? What are they asking me to do? And what yellow page am I heading to? Those you're gonna, the more you force yourself to do it on every single problem that you're working on, like the chapter 11 review worksheet, then you're going to get into that mentality for the final. If you just kind of hop around and kind of guess or refer a friend, phone a friend or ask April, you can do all those things, but it's not going to get you into the independence that you want to be for the final, right? Like you want to have a strategy, right? LeBron doesn't just show up to the NBA finals and win no, he plays, he practices like he wants to play. So you have to practice like you want to play. Okay, I'm off my soapbox. LeBron is the GOAT. What about Steph Curry and Draymond Green? See what?
Okay, Warriors fan.
What?
You must be a Warriors fan.
No, I'm a Michigan State fan, so I like to follow my old players.
Draymond, yeah, okay.
I
What
love-
even is basketball?
Huh?
Best sport ever.
Oh, the best sport ever. That's a high claim.
Mhm.
You know what the real best sport ever is?
Not baseball.
Oh, definitely not baseball. Definitely not baseball.
What do you think it is?
Because they
It-
punch each other.
European football, aka soccer. Best sport, in my humble opinion.
I hear your soccer and I raise you marching band competitions.
Kara, I
Drill
love
is
it.
hard to memorize, and usually on top of that, you also have to memorize the music that you're playing.
Yeah, it is.
All while walking and remembering to breathe and not to get run over by anybody else because they will not stop for you.
That is true. And to get all those poor people to coordinate at the same time. Mhm.
That's not including any extra movements, word and flashes, dances, anything else incorporated in.
I hear you, Kara. I don't. plain
But
and-
have you ever tried to defend someone a foot taller than you? That's the real question.
Yes,
Defend
yes,
and
yes.
band?
yes. I'm a whole 5 foot. It's very easy
To
to
defend?
find somebody 6 foot, find somebody about a foot taller than me and defend them. I've played sports. I have. It's not.
Drum line.
I will stick with my band and
You
my
stick
mental
with you.
games.
Oh, you do that.
You
School's a mental game enough for me.
guys are great.
Tennis is the ultimate mental game because you just get in your opponent's head and get them to screw up.
Tennis.
Tennis, yeah.
Mm.
You talk smack on the court. You talk while you're playing, like, oh, they ain't crap. Get in their head. Make
There
them
was
feel
one
weak.
game where I was smacking myself with my racket talking about cupcakes.
Smacking you.
They didn't know what to do with it. They got all like weirded out and then they started playing like crap. You got to do something when you suck. I'm not good at tennis. I just like tennis.
That's how I play golf. I suck at golf, but I have fun and then I throw my dad off so I can try and beat him.
Awesome.
Green.
So this is the part where I do my plea for supplemental instructors for the summer and fall. You do not have to be a perfect A student to be an awesome, amazing supplemental instructor like April. I don't know her grades. I'm just saying she's amazing, but you don't have to have the perfect 4.0 to do that. You do have to have a heart for helping other people. You do have to be taking at least 6 credits to be a supplemental instructor. I think that's for summer. I'm not sure about for fall, if you have to be full-time in the fall.
It's part-time the whole time.
Okay, so 6 credits at all
Yeah.
to be a supplemental instructor. It is the highest paying job on campus. But you're off campus. That's the goal thing right now. It does, I think, require that you have some tutoring hours. Is that right, April? Besides, like, you offer tutoring hours or just your?
I don't think you have to do both, but they would love you to do both. Because I had to shut down my tutoring hours because I was just so overwhelmed. But yeah, they like you to be able to do both.
Yep. And you could very possibly work with yours truly this summer. I am teaching 2 classes, 2 7-week stats classes. So you would get to hang out with me pretty much every day from May 10th until June 28th. If that's not enough to entice somebody, I mean, seriously, just send me an email and I will forward your information on to Terry Anderson. He does all the hiring for that. And they coordinate it with your schedule. That's the cool thing. And if it doesn't work with your schedule, that's okay. You can take a semester off. But and if you're like, I'm not, I feel pretty confident, but I'm not totally sure. it's just like when I taught my very first semester, it was like, oh my gosh, like I know how to do it, but to tell somebody else, I'm just not sure. That first semester, you're kind of relearning that with them. But that's the cool thing is, it's just like April, she sits in on the class. So she hears about how we talk about it in class, and then she kind of gets to relearn it from a different point of view instead of seeing it for the first time. She's like, oh, she's kind of getting to go through it again. So that's my plea. I know, Kara, this is her last semester. There's a lot of you, this is your last semester. It's like, dang, I get all these awesome students and then you're leaving. So if somebody's out there that's maybe interested, that's going to be here for another semester or two, 6 credit hours, just send me an email or a text, remind that.